Hi there, in this video I'm going to have a go at making the cylinders for the Upshur opposed twin. Now the cylinders are made out of sort of two main components really. You've got the sleeves and you've got the fins which sort of slot across on the outside. And the drawing suggests two options. First of all, the cylinders are made out of cast iron or steel, and the first option it suggests is using silver solder to solder the sleeves onto this piece of steel, which is the option I'm going for. The other option is to have a thicker piece of aluminium here, and to thread it, and to thread the ends and then screw them on, and then sort of fix them with something like Loctite or something like that. But I'm going for the first option. And what I'm also doing is, rather than going for a solid block of cast iron or steel, I've decided to go with CDS, cold drawn steel. And the internal diameter of this is 19 millimeters. The wall width is 3 millimeters, so that gives the outside diameter to be 25 millimeters, just short of the outside diameter of 1 inch, but that doesn't really matter. Now going with CDS allows me to first of all make pistons and cast iron rings to the specification of the inside of these once I've lapped them. But if that don't work out, I've got another option available. I can make some more pistons and use Viton rings. So that's sort of like, I'm just hedging my bets here. But first of all, what I'm going to do is I'm going to go for the first option, and that is to aim for making my own pistons with cast iron rings. Now, the actual sleeve has got a length of 1.932 of 1 inch. Now I've cut these pieces just short of 4 inches so I can get them in the chuck, and the outside diameter is going to be 0.937 of 1 inch, which will, or whatever that diameter is there, which might be slightly different to what it's saying here. And there's going to be a bit of a lip on here, if you call it a lip, which is going to have an outside diameter of pretty much close to whatever that is, and a width of 63 thou. So that's the plan. Okay, so I've set the depth stop to 1.869 from the front face of the piece, and I calculate I need to take off about 43 thou, so that's just over 20 thou each side. So I've just done a test cut on this edge here. That looks okay. Needs to be about 1 to 2 thou clearance for the silver solder. So I think that's good to go. Well, I'm always one for an easy life, so having marked it, I'm going to just chop it off. Now, when I've used this CDS before, there was no need to hone it, but I did lap it. So I've just cut this lap to be 2 thou smaller than the diameter of the sleeve. I'll just put a bit of this Molleroda lapping paste on, 500 grit. Give it a try. Probably don't need much more than that. It'll take no less than 1/10 of a thou off. But I'll clean it up and inspect it and see what we've got. Well, I think that looks pretty good. Not a mirror finish, but I think it should be okay. Well, they seem to work out okay. Very straightforward. But unfortunately, I've just realised I've not got enough round aluminium bar, so I'm going to have to order some more. Once it arrives, I'll get back to you. Okay, so the aluminium's arrived. I've cut this piece off 4 inches in length. I should get 2 sets of fins out of this. And what I'll do is I'll put it in the 3-jaw chuck on the lathe. I'll face this end off and turn this down to the proper OD. Once I've done that, I'll get back to you. Okay, so I've used a centre drill on this end, and I've offered some support with this live centre. Now, this is a 3/32 of an inch parting tool, which is about 93 thou. Now, the top fin, well, the fin widths are 63 thou, and this top groove needs to go to a depth of 78 thou. The other 6 grooves need to go to a depth of 187 thou. So I've just opened this up to around about 13mm with the drill bit. Now using this boring bar, I need to open it up to be 2 thou less in diameter than that outside diameter there. The idea being that I can heat that up and it'll expand more than 2 thou, and the sleeve will just slot in. So that's the plan. Well, this is certainly starting to get close. So I've set that to the absolute position there on 0. So if I go over to the sleeve, it should measure around about 2 thou more than that. One thou. Happy with that. So now what I need to do is to just cut a little recess in here for that edge to fit in there, but I'll do that a bit off camera. I think that's turned out okay. It's certainly slightly smaller than the sleeve. So I think what I'm going to do is I'm going to heat that sleeve up to 200 degrees C, put it on the press like that, and try and press it in. So here we go. Not exactly to plan that, is it? Oh, it's a shame. Well, that was a bit of a disaster, to be honest. I've bent this fin here and it still won't press home. I tried heating it again a couple of times. It's just that top edge here not sat right, and I reckon if I machine that off it's going to expose the underside of it. I had originally thought about making this this piece here slightly bigger than the outside diameter and using something like JB Weld to hold it together, but the only problem with that is when we get to come to silver solder this onto the base, it could break that JB Weld down. So I think what I'm going to do is I'm going to machine this off, try and recover the sleeve, and once I've done that I think I'm going to change my approach. I'm going to make a blank out of aluminium. I'll press fit it onto here, and that way if I have any problems I've not wasted all my time machining these fins, and if it works out okay then I can put that in the chuck and then I can machine the fins. So I think that's what I'm going to do, but I'm going to sleep on it. Well, having slept on it, I decided to try and push this sleeve out. Got it that far, but it won't go any further. I've tried making something to fit in there and press it out, but it's just rock solid. So I think what I'm going to do is, to rescue this, I'm going to tidy this area up here. You can see where it's pulled aluminium. And I did deburr the inside of this aluminium on the edges, so I don't know how that's happened. But what I'm going to do, I'm going to tidy that up a little bit with some wet and dry. I'm going to take a few thou off the edge here and underneath that lip. And it got a little bit bent there, so I'll sort that out. And then I think what I'm going to do is I will put a little bit of JB weld around this area here. I'll try pressing it back in again, and hopefully I'll have rescued it. That fin needs to be sorted out as well, assuming I can get this particular problem resolved. Well, in the end I couldn't use any JB weld because I had to heat this up with the blowtorch. Not perfect. I've tried to straighten that bottom fin out, but I think I can get away with it if that's on the bottom of the engine. I think what I'm going to do is put a little bit of JB weld in here, leave it overnight, then just skim this face off, and job should be a good one, I think. So this is my approach on the second one. I bored this out, this aluminium, to be 1 thou less than the outside diameter of this. Put it in the press, heated that up with a blowtorch, and it worked a treat, to be honest. So what I'm going to do now is put it in the lathe, cut the fins as I did on the previous one, and once I've done that I'll get back to you. Well, it certainly seems to be a better option cutting these fins while it's actually on the sleeve. Well, they seem to work out okay, got there in the end. So the plan now is to solder these sleeves onto this plate here. So you make a fixture like that, and then you clean everything up, flux it, put a bolt through, bolt it on the end, and then you heat from the bottom. And the solder I'm going to use is this Stay Bright as recommended. So this is the setup, and the idea is apply heat under here. Getting there, I think. Once heated up, it retains the heat quite well. It's just a matter of just sort of tidying it up with this little screwdriver. I mean, they recommend a little brush, which would be good, but I haven't got one. Well, they seem to have turned out okay. And if I was to do it again, I'd buy a little wire brush, just to finish off, put a little fillet on it. I just used a screwdriver, so it's a bit rough and ready. But it's amazing how well the setup retains heat. So this silver solder stays fluid for quite some time, and you can add pieces and it'll just flow. So like I say, a wire brush, that will probably be icing on the cake, to be honest. Apart from that, and a bit of a clean up needed, I'm pretty happy with the result. Well, I must say I thought the hardest bit would be the silver soldering, but it was a bit of a breeze, to be honest. And the stuff that's recommended in the drawing, Stay Bright by Harris, I think it's probably an American company, but you can get it in the UK. That seemed to work really well, and very easy to manipulate, because this retained the heat quite some time. Just a shame I didn't have a wire brush. Could kick myself for not having one of those. But apart from that, I'm pretty happy with the overall result. So I hope you enjoyed the video, and hope you all have a good Christmas, and I hope to see you later.